Hello everyone, and welcome to Linux Forensics here at Pentester Academy. In this video, I wanted to talk a little bit about obfuscation, things that people might do in order to try to make their code harder to understand and to obscure what it is that they're really doing. So I have here some files from the Xingxi Quan rootkit. Earlier, we looked at the bind shell program. We also looked at a stripped version, and we saw how that was different. And I briefly mentioned this guy. This guy is a packed version of this binary. So what's up with packed binaries anyway? The whole idea with a packed binary is that you can make something smaller, which might make it load faster depending on the situation. You're trading off disk size for computations required in order to uncompress the stuff into memory. Also, some people routinely pack their stuff in order to make it harder to reverse engineer. Now, thankfully, one of the most common packers by far is called UPX. So UPX is a cross-platform packer, and it works on Windows, Linux, and some other platforms as well. So that makes it very popular because it works in different places. Plus, it's free. People like free, especially people that are trying to hide their proprietary information. They want you to pay for their software, but they want to make sure you don't know how it works. So let's have a look at a packed binary in a hex editor just to see what this is going to look like. So I'll go ahead and run hex edit on this file, and you will notice a couple of things. It starts with the standard ELF header. Why is that? Well, it might be packed, but it's still an ELF binary, isn't it? It's still something that you want to try and run. Thankfully, it is pretty easy to tell if someone's using UPX, and here is the big clue. This string right there, UPX, will be in the file. So if you have that string right at the start of your file, it's probably been packed. Notice that there's a second ELF header, so to speak, in this file. So a couple of clues that this thing has been packed. You have the string, and then you have the secondary ELF header. So if I look at what's in this header, it's right here, right? It starts with 7F, ELF, and you'll notice there are some striking similarities between what's here and what's here. So again, it's a signature. So that's been repeated. And how does this work anyway? Well, essentially what it's going to do is it will load a small program which will take the rest of the code that's been compressed and expand it into memory when it's run. So if we were to try to run objdump and do a disassembly on this file, here's what we would see. Not much. Now you might say, oh, Phil, I think you just fat-fingered that command. Well, let me show you that I didn't. I'll take off the UPX. I'll even do the stripped file. And sure enough, I see code. So what's going on? Essentially, it has replaced everything with a big chunk of compressed code. What about GDB? We could try that. So let's run GDB on our binary. Now, again, I'm not running this in my sandbox. I probably should run this in my sandbox, but I'm not for this particular video. But whatever you do, don't start running this stuff on your forensics workstation. I will set this assembly flavor until I'll disassemble the main. And as you can see here, it's not liking it. All right, so this little packer has made it pretty difficult for me to look at this file. Now, as far as how you can detect this, as we've seen, you could run this through a hex editor, or you could even just use grep. So if I do a grep upx on all of my files in this directory, I see that binary file xingxi bindshell upx matches. So it's that easy. And again, this is a very common packer. People might use this in order to try to obscure code so that you can't figure out what they're doing. So how do you undo that? Pretty simply. Go download UPX and run it. Unpack the file, and then you'll have what you need. If a packer was the only method that they used to obfuscate their file, then you're probably good. However, there are a couple of other ways someone might obscure a file as well. So I would be remiss if I didn't at least mention these. There are also some obscure assembly commands that someone might use. Some of these obscure commands can be used as NOPs when you're writing shellcode, no operations, because a lot of systems are smart enough to detect a huge list of NOP assembly instructions. So programmers have gotten smarter, and they have found ways to do other things that are essentially doing nothing. So that's one thing. You might see obscure assembly instructions used. So how can you detect obfuscated code? If they're using obscure assembly commands a lot, that's one clue. Another way that you can detect obfuscated code, if they have hand-coded the assembly. Well, how do you know they hand-coded the assembly? It's pretty easy to tell because programmers have gotten good at writing compilers that have optimized code. The optimized code is also very uniform. So, for example, if you see anyone calculating by hand something that could be known at compile time, such as 2 times 4, then you can almost guarantee yourself that that person hand wrote that assembly code. Because if they wrote in C or any other language, my variable equals 2 times 4, it would automatically do that calculation at compile time and say my variable equals 8 and be done with it. So I would say that most of the time, if you see obfuscated code, again, if it's got a packer and or it has assembly instructions that are not common, and or you see hand-coded assembly, things that are not optimized, it is probably malware. Now, it's not always going to be malware. At the minimum, it's somebody that doesn't want you to see how their code works. Sometimes that's evil attackers. Sometimes that's evil corporate people. Hard to say which is which. Well, that's all for this video. As always, if you're enjoying these videos here at Pentester Academy, please tell a friend. We'll see you soon.